Today we're going to graph linear equations using intercepts. In the previous lesson we learned how to find the intercepts, and today what we're going to do is use them to help us with graphing. Knowing how to find the intercepts in order to graph saves you a lot of time. So the first thing we need to do in order for this to work is we first have to find the intercepts. So if you recall, there were two ways we could do this. We could actually substitute 0 in, or we could use the cover-up method. I'm going to use the cover-up method. So for the x-intercept, that means for the x-intercept, that means we're solving for x, so that means the y term is going to be covered up. So when I cover up this y term, I'm going to have 2x equal to 8 as my new equation. When I divide by 2, I get x equal to 4, so my ordered pair for my x-intercept is 4, 0. So for my y-intercept, I'm going to do the same thing. I'm going to use the cover-up method, but since I'm trying to find y, I need to cover up x. So I'm going to have negative 4y equal to 8. So I'm going to have negative 4y equal to 8. I divide by negative 4 on both sides. Y equals negative 2. So my ordered pair here is 0, negative 2. Now I can go ahead and plot my points. So I've drawn my lines already, and these are in intervals of 1. Here's my x, here's my y. So my x-intercept is 4, 0. So 1, 2, 3, 4. So right here. And 0, negative 2, 1, 2. Once I do that, then I can go ahead and draw my line through those two there. And that's it. So we use our intercepts and then we can graph it and we're done. Notice we don't have to make a table or anything like that. Now we're going to do it again over here, but if you notice this problem is a lot different because it has a whole bunch of fractions. So this is where some of our little tricks with dealing with fractions back from chapter 2 or when we were solving linear equations or inequalities comes in real handy. So if you recall, the way we can clear a fraction is by multiplying by the LCM of the two denominators. So in this case, the LCM of 2 and 3 is going to be 6. So what I'm going to do is take this and multiply this entire thing by that LCM of 6. This whole thing is going to get multiplied by 6. So that means every single term. So for our first term, we're going to have 6 over 1 times 2 over 3y equal to 6 times 4 minus 6 over 1 times 1 over 2x. So now I'm just going to use my regular algebra skills and my number sense here. 6 times 2 is 12, divided by 3 is 4. Some of you might see to cross cancel these first, that's fine. 6 times 4 is 24. And I'm going to have a negative. 6 times 1 is 1, divided by 2 is 3. So now I have a much nicer problem to deal with. So again, I'm going to use the cover-up method and actually solve it. Now, I didn't technically have to do this. I could have left it as fractions and solved. But if you didn't want to deal with the fractions, then you can use this shortcut. So, cover-up method. Cover-up method says for the x term first, I'm going to cover up the y. If I cover up the y, then I'm going to be left with something that looks a little bit odd. I'm going to have 0 equal to 24 minus 3x. That's okay. We can still solve it. I would move the 3x over here by using our inverse operations and then divide by 3. X equals 8. So my x-intercept is going to be 8, 0. Now for the y-intercept, same idea. I'm going to do the cover-up method. So this time I'm going to cover up the x-intercept. So this term's going to go away. I'll be left with 4y equal to 24. So I'll divide by 4. Y equals 6. So my y-intercept is 0, 6. So now I can go ahead and graph them. This is 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to have 0, 6, 1, 2, 3, 4, 5, 6. And then I can go ahead and draw my line between these 2 points. Right there. So when using intercepts, all you have to do is find the intercepts and then plot the points to graph.